Second graph, inverse tan. Remember that the basic form for inverse tan of x is it's a graph that has those funny horizontal asymptotes, okay, and has that kind of shape. And those asymptotes are at negative pi on 2 and at pi on 2. So for us, for this graph, we're going to need to have a look at the translations that are happening in there. So we've got y equals inverse tan of x plus 2, and it's plus pi on 2. Now, the first thing that you notice here, we've got x plus 2 happening, okay, inside the angle here. Now, normally our domain for inverse tan is between negative infinity and infinity, okay? That's if we have x, all right, if we have inverse tan of x. Now, because we have inverse tan of x plus 2, you'll actually find here that it makes really no difference. The reason for that is if you put a plus 2 in here and you take away 2 from each side, infinity plus or minus 2 is still infinity. It's still massively big. So this actually doesn't do anything to change the domain. The domain remains the same. Okay. We do have a translation though. So we have a translation which is positive pi on 2 going up. Okay, so what that's going to do is it's actually going to move everything up, and it will actually move this as well up. Okay, think of this as a kind of center point. So we're going to have our new asymptotes at 2 places now. So one will be at x equals 0, I should say y equals 0, so horizontal, and the other one will be at y equals pi, because you've actually moved everything up pi on 2. Okay, the center point, which we can think of here as a sort of turning point, okay, is going to be, rather than being at 0, 0, it's going to be translated up pi on 2, and it's also going to be translated left 2. Remember that whenever you've got that value inside the angle, it's always the opposite of what the sign is here. So we're going to actually have that turning point occurring at negative 2 and pi on 2, as opposed to where it normally occurs, which is 0, 0. Now we can graph what we know. So I'll just put some axes in. We know that we have an asymptote at 0, so you don't really need much below there. And then we can put in, label our axes, so y and x. Put your horizontal asymptotes in. So we've got we've got an asymptote at y equals 0, and we've also got another asymptote, and you would rule these, another asymptote at y equals pi. Okay, there are 2 asymptotes. And we've got that turning point. It's been moved over to negative 2, so negative 2 and pi on 2, which we could say is there halfway between. And the kind of shape, we've got this kind of shape. Okay, so a shape like that. Right, and we've got our turning point here, negative 2 and pi over 2. Now with this shape, you can see that you've also got an intercept here. Now in your book, in your textbook, they don't actually label that intercept, but you could with your calculator find what that value is. The reason that you can't really do this by hand is that if you put x equals 0 into your function here, you end up with a non-standard angle that you're looking at, inverse tan of 2, but you could certainly use your calculator to find out what this value is. For a non-standard angle like that, they wouldn't expect you to put the intercept in here if you're doing it by hand. But that's the basic shape that you want for your inverse tan graph.